In this video, you're watching lesson 2 on probability. This lesson will focus on creating tables for probability. In the previous lesson, we talked about tree diagrams. In this lesson, we'll show an alternative way of calculating probability. So we know we can use tree diagrams to calculate and show simple probabilities, but they're not always so neat. So here we have two coin flips, and a tree diagram is basically perfect for events that don't have too many outcomes. Here we have one coin flip where you could either get heads or tails. Only two options, right? 50-50 chance. Well, then you also have a second coin flip, and you could get heads or tails on either one. Well, based on the coin flip on the first one, you could get heads, then heads, two heads, or you could get heads, then tails. Alternatively, you could also get tails and heads and tails, giving you a total outcome, total number of outcomes of 4. So another word for that would be our sample space. If you reviewed our previous lesson, our sample space or total number of outcomes is 4. And if we were looking for example, the probability of getting heads and heads, well, only one outcome is heads and heads. So our probability would be 1 in 4, right? And we can see that using a tree diagram. Well, let's take another example. You have 2 dice instead of 2 coins. What is the total amount of outcomes that can occur? In other words, what is our sample space? What are the total number of outcomes we can have? Well, if we were to show this, we would see a tree diagram that looks something like this. We would have the first die, 1, 2, 3, 4, 5, 6, easy, but then each one has 6. And so it starts to get messy and large and a little bit trickier to calculate. Now, the advantage of tree diagrams is that they're quick and easy to see which probabilities you have and figure out what the probability of certain events are. But when you end up with more than 10 total outcomes, or if your sample space becomes more than 10, 20, 30, then your tree diagram takes up too much space and can potentially take too much time. So if you end up in a situation where you have too much in your sample space, you can do a table. So for probabilities where the sample space, the total number of outcomes is large, tables can be used. So a table like this, we can go, okay, well, we'll have one outcome here, and all the number of outcomes for that one event. For that one event, these are all the outcomes for that one event. And then we can put the number of outcomes for the other event here. And so where they meet, like on a grid, is the probability of any one event. So let's take a look at our previous example. We have 2 dice. Just like before with our tree diagram that's too messy, we have 2 dice. Well, how many outcomes are on one die? Right? Well, we know that a normal die, has 6 sides. Well, then we have 2 dice with 6 sides. And so we create a table where this top part is one die, and this side part is the other die, right? You can get 1, 2, 3, 4, 5, 6 on one die, 1, 2, 3, 4, 5, 6 on the other die. So then your probabilities or your outcomes come in to each box. So what is the probability of getting 2 ones? Right here. And there's no way to get another set of 2 ones, so you know that it would be 1 out of the total number of probabilities or outcomes, sorry. So you can look and see what the total number of outcomes are, and you can see what each outcome is. So we'll fill this guy in, and we'll get a table that looks like this, right? Rolling 1 on one die, rolling 1 on another die, rolling 2 on one die, rolling 1 on the other die, 3, 4, 5, 6, and then 2 on this side, all the way up. And so each square gives one outcome that is possible for our events. So in this case, we're using 2 dice. So it's giving us the probability, or it's giving us every outcome for rolling 2 dice. Okay, well then what is our sample space? Well, you could easily count it up 1, 2, 3, 4, 5, 6, and just keep going through it. Or you could use some multiplication. Now, this is an example of where your previous multiplication practice comes in handy, right? You have a row of 6, right? Each row of outcomes is made up of 6 squares or rectangles. And you have 1, 2, 3, 4, 5, 6, 6 rows of 6. So you have 6 rows of 6. Well, that's the same as saying 6 times, or 6 times 6, right? So 6 times 6 is 36. So our sample space, our sample space is 36. We have a total of 36 outcomes for our 2 dice. And that's based on this table because you can see we have 6 on each row and 6 rows of 6. So 6 rows by 6 rows of 6. Yeah. Okay, so now that we have a table with a sample space, we can now find the probability of any problem related to it. We can calculate the probability of any outcome, right? If you pick an outcome based on rolling 2 dice, we can calculate it using this big table. Okay, so an example. What is the probability of getting a sum, right? Now, hopefully you know this word, a sum, higher than 7. If you don't know what sum means, you need to review grade 7 vocabulary, because sum, or a sum, means an addition, adding. So if I'm saying what is the sum of this, I'm asking for what is the addition, the operation of addition answer. So if I'm saying what is the probability of getting a sum higher than 7, I'm saying what is the probability of getting 2 numbers on dice where their numbers added together is larger than 7. So I'm looking for where you get 2 dice rolls and the numbers added together is greater than 7. So, for example, let's look at 1 and 1. Well, 1 plus 1 is 2, so it's not greater than 7. That's not part of the outcomes we're looking for, right? 1 and 2, no, no, no. So let's start high. 6 and 6, well, that's 12, so yup. 5 and 6, yup, yup, right? I'm just marking them and so forth as we go through, right? And as you go, you can see that the numbers are being filled in as we look through our table, right? We look at our table and we go, okay, which outcomes fit in our results? Which outcomes fit in our results? And we just sort of highlight or mark which outcomes meet our question or what we want. So a better picture would be like this, right? So we can see the question's asking us, what is the probability of getting an outcome where the roll of both dice add up to something more than 7? Well, each of these, when you add these 2 numbers together, they're more than 7. Don't pick 5 and 2 or 4 and 3 because that is 7. We're looking for more than 7. So when you count those up, you have a total of 14 outcomes that are greater than 7. Well, if you remember our previous lesson, the way to calculate probability of any event is outcomes we want divided by total number of outcomes. So outcomes we want, or what the question is asking for, so what we want, over the total number of outcomes. The total number of outcomes. Right? Okay. So then our probability becomes outcomes you want out of the total number of outcomes, or our sample space. We have 14 out of 36. That is our probability. Well, a common mistake would be to stop right here, but you can make it simpler. Divide both by 2, use 7 over 18. There we go. Or convert it into a decimal, 0.39, or convert it into a percent, and you realize you have a 39% of rolling 2 dice and getting a number, when you add those two numbers together, larger than 7. So you have less than 40% chance. And that's how you calculate using a table. So what is the downside of having a table that a probability tree does not have? So what is the downside of using a table that a probability tree would not have? Right? This is sort of a thought question, because you have two methods now. You have the tree and you have the table. Well, you want to be able to make the decision as to which would be better for your situation. We just talked about how the tree gets messy when you have a large sample space. When your sample space gets too large, then your tree gets ugly and it's hard to read, and so it defeats the purpose of using the tree. So when would you use a tree instead of a table? Well, when you have a small sample space, right? Small sample spaces, a tree is quick to draw. It's easier to draw than a table. You don't need to collect all the outcomes of one event and then the other event. You can just work through the tree and you will get your answers. So trees, probability trees, are good for small sample spaces, while tables are good for your medium-sized sample spaces. In the next lesson, I'll show you a faster way to calculate probability, but these are good ways to visualize probability. These are good ways to understand how we come up with our calculations, because I will ask later for you to draw a tree and for you to draw a table. So here are some questions you can do. Questions 5, 6, 7, and 11 on page 417. Hopefully this lesson was useful, and I'll see you next lesson.